Conditional variance. Now, conditional variance is the variance of y given x is equal to x, and this thing can become very complex very soon. So we'll go directly into the formulas that we need to answer the solve some questions. What variance of y is variance of y given x is equal to x. So what would that be? That would be expected value typical formula for variance is just expected value of y square given x is equal to x minus expected value of y given x is equal to x square. This is same as the typical variance formula, which would be expected value of y would be expected value of y square minus expected value of y square. So this comes from that formula. And after you solve with some algebra, you get to a formula of expected value of y is equal to we come to a law of iterative expectations, which means expected value of y is going to be expected value of y given x, expected value of the expected value of y given x. So this is the unconditional expected value of unconditional expected value of random variable y, and this here is the expected value of the conditional expected value. So that's the expected value of y, but the law of total variance, then there is a law of total variance which says that the variance of y is going to be expected value of variance of y given x So this is the same as this one. Expected value of y is the expected value of y over x, and here we have expected value of y is expected value of variance of y over x plus variance, but here is one more thing we add here, variance of expected value of y given x. Variance of y is expected value of, so unconditional variance of y is expected value of the conditional variance of y given x plus the variance of the expected value of y for x, which is the same thing as here. Let's try this question, which is we roll a die, and we get a number x, then we toss the coin x times. Y is the number of heads we get. Now if we know x, then the distribution of y is just a binomial distribution where x is equal to little x. So y is binomial with the parameters of x and p, where n is replaced by x because we know the x. So function of y given x, which is the PMF of conditional PMF of y, is going to be x instead of n, and y, probability of y, because y is what we want to know, is the number of heads or number of successes, and 1 minus p x minus y, x is in place of n. So that is the PMF. So but now if we take it, if we want to know what is the expected value of y, expected value of y given x is going to be x into p, which is, instead of n, we're going to call it x, because expected value of a binomial variable is n times p. So that is xp. So what is expected value of y? Expected value of y is going to be expected value is defined as expected value of y given x. We've seen this here, law of iterative expectations. Expected value of y is expected value of the expected value of y for x. So, but expected value of y for x is xp, so then it becomes expected value of xp. Since p is a constant, p comes out, it becomes expected value of x. And we know the expected value of x is just the rolling of a dice, so the expected value of that x is going to be 3.5. So expected value of y is going to be p, which we are tossing a coin, so that is going to be half times 3.5, so this is going to be 1.75. So that's the expected value of y. But what if we now ask what is the variance of y? So now if we want to know the variance of y, we have to go into this formula, which is expected value of variance for y given x plus variance of expected value of y given x. Now variance of y given x, that is again a binomial formula, so that's going to be xp 1 minus p, because the variance of a binomial distribution is np 1 minus p. So you get this here, and since this all is constant, it comes out p 1 minus p, and then you get just expected value of x, and expected value of x we have seen is 3.5, and that is 1 by 2 times 1 by 2, that is 1 by 4 times 3.5. So we got that taken care of. But now we have to deal with this thing. What is the variance of expected value of y given x? But we already know expected value of y given x is is xp. So that just becomes variance of xp. P comes out, and then you will remain with variance of x. Now, no, P doesn't come out. P becomes P square. So here is another concept. When we have a random variable, say x, and we multiply it by c, so the variance of cx is going to be c square x. So that is what we are doing here. The c square comes out and it becomes variance of x. Now variance of x is basically, you have to calculate this x goes to the rolling of a dice thing. So that is expected value of x square minus expected value of x square. Now expected value of x you have to calculate all the way back, and then expected value of x we know is 3.5. Expected value of x would have to be calculated by like 1 square times 1 by 6 plus 2 square times 1 by 6 plus, this is the x because we are squaring the x, 3 square times 1 by 6 plus 4 square times 1 by 6 plus 5 square times 1 by 6 plus 6 square times 1 by 6. That's the expected value of x square. And expected value of x we know is 3.5. So you basically take out the 1 by 6 here, and then you do 1 plus 4 plus 3 plus 9 plus 16 plus 25 plus 36. That is going to be 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided by 6 is going to be 15.1. So this is going to be 15.1 minus 3.5. That is going to be minus 3.5. That is going to be 11.6. So variance is writing here, variance of y is going to be 3.5 divided by 4, that is 0.875 plus 11.6. So that is going to be 11.6 plus 0.875. That is going to be 12.475.